Okie doke, welcome. I'm going to take you through the exercises for the environmental policy course, one at a time. And we're going to start with perfect markets, exercise 1. Hopefully each one's going to take about 10 to 15 minutes. So, we're given a firm's profit function. Pi profits are P times Q minus C of Q and A. So costs are a function of the quantity produced and abatement effort. So this is the abatement kind of conceptual framework. And we're told P and we're told C and we're also told that there's a benefit function for the environment, I equals 4 plus 3A minus Q. You might wonder, where does this come from? And I could wonder that too, and what's this fixed term doing there? You could ask yourself, but whatever. Abatement effort is giving positive benefits. Production without abatement is thus taking away those benefits, and if it's big enough, there'll be damages. And the firm's a price taker. Derive the firm's cost for achieving different environmental impacts as a function of the target I. Okay, so how are we going to do that? Well, we're going to be doing a lot of this. We're going to think of this as a restriction. So we're going to say, well, let's imagine we've given the firm a target, I, or I bar, even, we're told. And then, to fulfill the target, the firm needs to make sure this holds, and that is a restriction on the firm's profits. So then we can write that L, the Lagrangian, is PQ, and we're told that P is just 16, so P is constant, PQ minus C of Q and A, and the cost function is 2Q squared plus A squared. Remember the brackets, and then we've got the restriction plus lambda times the restriction, which is I bar minus 4 plus 3A minus Q. Okay, so that's our Lagrangian. I hope that's reasonably straightforward for everybody. If it's not, you're going to be getting plenty of practice with setting up Lagrangians and solving them in this course, I can promise you. Okay. So, let's take first order conditions. In the choice variables, A and Q. So, the first order condition in A is derive this with respect to A, you get nothing. Derive minus A squared with respect to A, you get minus 2A. And then we've got lambda times this, 3A differentiates to 3, and we've got a minus 3 lambda, isn't it? So it's generally nice to have lambda positive, so why don't we change the sign of this? Then we're going to have minus minus plus 3 lambda equals naught, and then we can rearrange and bring the 2a over and write like that instead. So that's our first order condition. And the first order condition in Q gives us P minus 2Q minus is minus lambda. So equals naught minus lambda equals naught, so P minus 2Q equals lambda. Okie doke. So, and finally, we've still got this equation, haven't we? Which you could get back by taking the first order condition in lambda, but we don't. That's a bit pointless. So why don't we eliminate lambda from these two? And then we've got two equations in A and Q. So if we multiply this one by 3, we've got 3p minus 6q equals 2a. So, got that equation and that one. And we can now eliminate either P or A. Sorry, not P. P's known. Q or A. So we've got 2A here. Why don't we... Oh, no, that's tricky. We've got 6... Trying to decide what to do. Let's take 3 times this one and say, just spin the chair a bit. Okay. We're going to take 3 times that one, so we've got 9p minus 18q equals 6a. And we'll take double this one. So 2i bar minus 8 minus q is plus q times 2 is plus 2q equals minus 3a, take that over, plus 3a times 2 is 6a. Okay. So I'm doing things, you might choose to do these in multiple steps, but hopefully with the benefit of replaying the video you can keep track of this. So now we just put these two equal to each other. 9p minus 18q minus 18q is 2i bar minus 8 plus 2q. Okie doke. So 9p plus 8 is 2i bar plus 20. Q, and we might as well put in the value for p, which we're given, which is 16. Wow, this is pretty gratuitous, isn't it? So what are 9 16s? 160 minus 16 is 144, plus 8 is 152. So 20q is 152 minus 2i bar. I wonder if that's really correct. don't think so. Oh! Pause the video. Okay, about 30 seconds later, who spotted my deliberate mistake? It's here, isn't it? 4q. P minus 4q is lambda 3p minus, okay, so what do we do here? Yeah, 3p minus 12q is 3 lambda, so 3p minus 12q is 2a, yeah. 3p minus 12q is equal to 2a, so that's good, so our strategy here is still working, because we multiply that by 3, 9p minus 36q is 6a, 9p minus 36q is equal to 2I bar minus 8 plus 2q, 9p plus 8 is 2I bar plus 38q. Okay, so 9p plus 8 is still 152 minus 2I bar. Is 38q, and 4 38s are miraculously enough 152, so we end up with q is 4 minus 2 over 38, which is 1 over 19 I bar. Okie doke. So, we've got q. Now we need a, which we get by sticking that value of q into here and doing some more algebra, and we get, from that, we get, can you see this? Yeah. A is, I've got a crib sheet here, 6 over 19 times I bar. That's super straightforward here, so I'm not going to go through that. Stick this value for q into here, for instance, and you'll get the answer, or even, yeah, into here. Anyway. Okay. But still, we haven't got the answer. How do we get the answer? We need to put all this stuff back. In particular, we need to put this and this. Where's my eraser? So, take away those red marks. Now, these are the two key ones. The answers for Q and A, we put them back into the profit function, which is PQ minus 2Q squared minus A squared. Okay. Wow. So there's some pretty messy algebra in these questions, isn't there, which is a shame. But let me take you through this. So PQ, what was P? P was 16, I think, wasn't it? Yeah. So 16 times 4 minus I bar over 19. That's PQ, isn't it? There's Q. Minus costs, which is minus 2 times that squared, and then minus A squared. Whoops. 6 over 19 squared I bar squared. Okie doke. So that's our expression for profits. And it turns out, when we multiply this out, this one, we end up with terms in I bar squared, and then the term in I bar is minus 4 I bar over 19 times 2. It's minus 8 I bar over 19 times another 2 is minus 16 I bar over 19, and the minus turns into plus 16 I bar over 19. And here we've got a minus 16 I bar over 19. So it turns out that the terms in I bar disappear, and we end up with just a number and a term in I bar squared, which is 32, 64 minus 2 times 16, and then the I bar squared term is plus 2 I bar squared over 19 squared minus 36 I bar squared over 19 squared. So that should be minus 34 I bar squared over 19 squared. No, that's not right. Whatever. Why do I keep trying to use this red one? Minus 219 I bar squared. I'm going to stop the video and check. Well, yeah, the problem is just me trying to jump over steps, isn't it? Really, you should be writing all this out, taking much more steps. But actually, the term here is plus I bar squared over 19 squared, minus 2 times that. So it's minus 2 over 19 squared, and then we've got a minus 36 over 19 squared. So we've got minus 38 over 19 times 19, which is minus 2 over 19. So that is profits. So what's the answer to the question? Well, when I is naught, then profits are 32, and the bigger I gets, the less profits are going to be. So what's the sketch going to look like? So this is the cost, isn't it? So the sketch, it's like super straightforward. It's just going to be something like this, isn't it? Because the costs, 2/19 I bar squared. So when I bar is naught, there's no costs, then it's going to go up like that. I'm going to pause again for a break.